Hello, everyone. Welcome to my stream. Hopefully, this stream will actually work. So to recap, um, I have created two previous streams. The first one, it turned out, wasn't recorded at all, and the second one, I was recording a blank screen the whole time. So this will be my third attempt, and hopefully this time everything will work. Yeah, and as you can see, this time everything looks better. So let's get started. So this series of streams that I'm starting on, where I'm gonna be creating a project, a computer game, and it's gonna be modeled after the Suika game. And Suika game, let me just pull that game up, picture of it. Yeah, so I'm basically going over things that I talked about in my previous two streams, but because they weren't recorded correctly, so I have to do it again. So, Suika game. This is what I'm gonna be recreating. It's a game where you drop fruit into a box, and if two of the same fruit touch, then they combine to produce a bigger fruit. And you just keep going until you produce a watermelon, which is the biggest fruit, which is this guy here. And once you create a watermelon, it disappears, which clears up space for you to continue dropping fruit into the box. And if you reach the top of the box, then it's game over. So you just keep dropping fruit and see how high of a score you can get before you reach the top of the box. Kind of like Tetris. Yeah, so this is a game that I want to create. It's a pretty simple game. And I could do it using JavaScript, but I from previous experience, if I were to just use JavaScript, I know that it'll get laggy and slow, and the fan will spin up after a while if there's too many things going on the screen. So I was going to use WebAssembly. You know, I heard of WebAssembly before, but I've never used it, and I don't know much about it. So I was gonna use WebAssembly, but then I just I just started reading up on WebAssembly and found out that it's not what I thought it was. So I was looking for a way to make the graphics run faster, or take up less system resources. And WebAssembly isn't that. WebAssembly actually is a tool. So traditionally, so I'm making this to back up. I'm making this computer game as a web browser game, so you can load it up on a web browser and play it anywhere. And I want to also be able to make it offline, so you can play it even without an internet connection, as long as you load up the game first. Um, so traditionally, in order to have something running on a web browser, you need three things. You need HTML, CSS, and JavaScript. HTML is just the original markup language used to show whatever's on the web page. CSS came later, which was styling the web page, and then JavaScript came after that, which allowed you to uh, make things more dynamic. So basically, in the 2010s, we had a huge Web 2.0 um, revolution, which was all about using JavaScript to make websites more interactive. So, but since then, everything is still written on JavaScript, and that has performance issues if you have a lot of things going on. So wanted to look for a way to, what's the cutting edge with web browser technology to speed up or make the game as fast as it can be, or take up as little resource as it. So after I discovered that WebAssembly wasn't what I wanted, I started thinking more and researching and discovered that what I was actually thinking of was WebGL. And WebGL, it um, exposes the hardware, the graphics hardware of a computer. So it would be the graphics card or the integrated graphics, basically the GPU, which is a lot more. It performs a lot better with rendering graphics. It's a lot faster. Um, and so WebGL gives JavaScript the ability to use the graphics card. Um, yes, but I don't have any experience with WebGL. So one of the purposes for this stream is I want to take everyone on a journey of what it's really like to be a software developer. So I'm not gonna be doing research on my own, and reading up and coding up stuff and then just sharing it on the stream. I want to like everything I'm doing regarding this project, I want to do on stream so everyone can see, um, you know, basically all the steps to and what it's really like being a software developer. So yeah, so I started following the tutorial on just yeah, I just Googled and found a tutorial, WebGL. And I started, and originally I thought I could just put together a basic, a game as simple as it can be, which really, if I think about it, it only needs two files, a HTML file and a JavaScript file. And so that's what I started off with. But uh, when I loaded it up, I was getting something like this. And there's a JavaScript there, which yeah, it's related to the core policy, which is the cross origin. So in short, what it means is that HTML files are not able to load JavaScript files um, just by itself. Like I can't open a HTML file on my computer and have it load up JavaScript files. Or I guess it's a security vulnerability. So I Googled, so how to open locally. I think this was my search. No, it wasn't. Um, okay, so I think yeah. So I Googled and found a link to looking for a workaround. How like so it doesn't work doing it just HTML file with a JavaScript file on my computer. So is there any way to that it could work, or what do I need to do to get it to work? And the conclusion is basically that I need a web server. So I need to create a whole web application and wrap it around this game that I want to create in order to be able to load up the game. So since I'm writing in JavaScript anyways, the what makes sense to me is to use a Node.js web framework, and the most popular one is Express. And so, yeah, so I spent the first stream basically figuring this out and then installing Express, using this npm install Express save, and then creating a whole basic web application using it, which is which creates all these files, and I put it under Suika Game. That's the directory. So yeah, so I created a basic uh, app, basic web application, and hooked it up. And yeah, and I had to make a few. So basically, the crux of it all was just to be able to render the game file, the HTML file, and then the HTML file will create a will load up the JavaScript files that it needs. So the key with just this basic web app is here. It's just it exposes the public directory where I can just put my static files in there, and then I can just access them. So going to the public directory, so that's where I dropped in my game.html, and then they broke up the resources into images, style sheets, and JavaScripts, and so I put my JavaScript files in here. So to load up the server, I use npm start, and this is all just default. The default from just generating a Express web application. So once I do npm start from the command line, the server starts to run, and then just and as you can see, this is where we left off in the tutorial from the last stream, which I recorded, which ended up just being a blank screen the whole time. So yeah, so I started following the this tutorial, and you can see it has the same loading box moving around. Um, yeah, so the tutorial, I originally wanted to put all my JavaScript, all the code in just this game.js file. The tutorial wanted to create 3 JS files. So I combined 2 of them into modules.js, and game.js still has the main stuff. The tutorial relies on another third-party JavaScript library called GL Matrix, and that's an open source JavaScript library. From just the name, I think it does the heavy lifting with regards to matrix operations, which is a graphics thing. Graphics use a lot of matrices, and GL I think is just geared towards WebGL. So, um, yeah, so I started off at the very beginning, which the first tutorial it loads up a black background. The second tutorial it loads a white box inside of that black background. So it just the subsequent tutorial builds upon the previous tutorial. So it's a white box next, and then it creates a gradient box, or it colors that white box with a gradient, and that was just a white. So for this tutorial, there were 4 vertices, and I put a color for each vertex. So one of them is white, one of them is red, one of them is blue, one of them is green, and then um the code, or the I guess WebGL knows to interpolate all the colors in between, so it creates this nice gradient. Then the next box and the next tutorial was about rotating this box. So even though it looks like the box is rotating, the what the code is actually doing is it's rotating the camera. So imagine that we're turning our face, and the box is actually staying the same. And so looking back, thinking back, how this will apply to the game, Suika game. Yeah. So in the Suika game, want the objects to be moving and not the camera. So this tutorial, even though it's nifty, it's not gonna work exactly this way. It's not directly applicable to what I want to do. So this next tutorial, the next page is about. So we had up until now a 2D box. Now we or 2D square, and then now we make it into a 3D box, and then each of the faces we make a specific color. So yeah, so this was took about 2.5 hours on my stream on my previous two streams. Um, yeah, so now let's move on to the next tutorial, and I'm planning on just finishing all these tutorials, and then once I have a grasp of the WebGL's capabilities, then I can start Googling for all the missing pieces, and then go from there. So one thing to note is that WebGL exposes the graphics to JavaScript. And so ultimately, I'm still having to use JavaScript as the programming language, which works out for me because I'm pretty familiar with JavaScript. Okay, so this tutorial, it's about, so now that we have a 3D cube, now we want to texture it. So so up until now, it's just solid colors. So let's see what it is to texture, which I'm not really familiar with, but we'll find out in the end. Okay, so let me load up the JavaScript files or just open them. And I'm just using Notepad to code because that's how, yeah, real men code. Or I mean, just people who have people who can code in Notepad, or I don't know how to put it. Okay, so WebGL demo.js, that corresponds to game.js. That's what I named my file. So add these two functions. So let's see, load texture and is power of two. That's interesting. So is power of two is just a helper function, just basic. But let's see. So I have load text, um, load shader. So I'll put a load texture after load shader. Okay, so that's interesting. Takes a URL argument. Okay, so it's gonna involve. So the URL is to a image. So just I might optimize this later by just having the image locally. Yeah, so I'm just copying this code over and also trying to make sense of it as I'm typing it out. Hmm. So RGBA, that's red, green, blue, alpha, and alpha is the opacity. And so this is blue, which makes sense. It's so RGB, so the R red and green are set to 0. Blue is set to the max value, 255, and then opacity is also maxed out, so you get a blue color. Next image 2D. So I'm thinking the texture could be applicable to the game I'm creating. Um, I'll create images for each of these fruits and then be able to load them and have the picture uh, have them as textures. So one thing that I've been thinking about is, this is about making squares and boxes. The game, the game does not have, well, it does have one box, but the fruit is all circles or spheres. So that's going to be interesting to figure out how to make those. So that's interesting. It's setting this image source to the URL at the very end. So this is power of two function is interesting. So it's either the value or the value minus. So the value needs to be true, which means it's not 0, and the value minus 1 also true. Hmm, that's interesting. I'm not quite sure what this does, how this works. But it's interesting. So it starts by calling the texture object, um, and uploads a single blue pixel. So it'll start off as blue, and then once the image loads, then it'll create the image, or it'll make the face the image, text image 2D. Okay, so power of two. So this is why. So it's interesting that WebGL can only use non-power of two textures. So if it's power of two, WebGL can do filtering, higher quality filtering. Hmm, interesting. So, seems like if it's power of two, WebGL has more optimizations that it can do. And if it's non-power of two, it can still handle it, but it'll be slower, or it'll consume more resources. So seems like there's two coordinates S and T. I don't know what either of those mean, but it's good to keep that in mind for later. File it away in the back of my mind. Hmm. Top to bottom. So it's like rasterized. Well, not raster, but just yeah. Okay, interesting. WebGL wants it from bottom to top, bottom left. They both start from the left. Huh. Oh, orientation. Oh, pixel store eye. Okay, interesting. So it's not gonna matter that much for us, but it's interesting. Low texture. Okay, so main function. So after init buffers, after init buffers, then a little texture. Cube texture. So it's a PNG. And this pixel store eye is to prevent the image from being upside down when it renders. Okay, so yeah, so I can. Oh wow, just save Firefox under the public. Let's see. So I do have an images directory. So if I save it under there, um, then I might have to change the URL as well. Let's see if this will work. Images, mapping the text. Init texture. Okay, so init buffer.js, that's one of the files that I have inside of modules.js. So init buffers. So I have init buffers, init color buffers now, init position buffer, init index buffer. I think I'll put this new function, init texture, in between color and position. So interesting, front and back, they're exactly the same. Wasn't expecting that. Oh, front and back. Okay, maybe, yeah. Let me see. So they are actually all identical. That's interesting. I wonder what that means. But um, what that means from a coding standpoint is that I can just copy and paste. So it creates a buffer. There's been a lot of buffers. WebGL buffer. So we store the texture coordinates for each face in this buffer. Then we bind the buffer as an array. So that's just setting it to the texture coordinate buffer, and then returning it. So then we can manipulate it later. Texture coordinates, dimensions. Update init buffers. Okay, so now we're gonna replace the colors or the solid color faces for this. So in it, so let's see. So init buffers. So I'm thinking the yeah. So let's see. Const. So now instead of color, we're gonna do texture. All right, updating the shader. Shaders to be images or textures instead of colors. So this is the main function. The vertex shader. Replace the vertex shader. So that instead of fetching color data, it fetches the texture coordinate data. So that would be via source vertex shader. Let's see. So that stays the same. That's okay. So instead of color, it's now chord, texture chord. Oh wow! So it's not vec4 either. It's vec2. Hmm. Then map for U model view matrix, map for U projection matrix, varying high P as opposed to P. Vec2. E texture chord. Hmm. GL position, U projection matrix, U model view, A vertex position. So instead of color, we go texture, A texture color. Yep, instead of fetching color, we're fetching texture. Fragment shader. Varying vec2, same as that one. The texture. And so this is new uniform SAM 2D view out vec4 frag. So it's I think it's changing or it's taking the texture and converting it to a color. Frag color. Oh wow, no GL frag. No, or GL, just frag color. Hmm. Text text cell. Pixel with okay. Cool. Yeah, this is good description. The fragment's color is computed by fetching the pixel within the texture based on the coordinate. So this will be very useful when it comes to creating spheres or circles and making their texture a image of the fruit. program info. Okay, so we need to set these new variables that we just created. Get attribute location, a texture coord. Uniform location, projection matrix, new projection matrix, model view matrix, new model view matrix, and then a new one, new sampler. Okay, now changes to the draw scene function. Add the following function. Draw scene, that's also, yeah, so draw scene JS, that's the second file in modules. So draw scene function. Okay, so I'm supposed to add this function inside of the draw scene function. See what other functions I have in here. Draw scene. Because if I don't have any other functions, I want to just put it outside, like the set position attribute. Yeah, I have set position attribute, set color attribute. So let's just add another. Set texture attribute. So these are just variables or parameters. Okay. So I need to also replace this call to set color attribute. That be here. So before it was setting the color. Now I need to set the texture. TL buffers, program info. Just after the two calls to interesting texture 0. Uniform 1i. Oh, uniform 1i. Okay, so texture 0, that's out of 8 of them. So inside the main, I want to add to the draw scene. Draw scene render. Okay. Yeah, and texture was just loaded previously. Oh wow. All right. Let's see. So we're done. Let's see what we get. An error. Okay. Modules 189. Error there at line 189. 67. 78. 88. 89. Let's see. Oh, Mr. Comma. Okay. Use sampler. Syntax error. Attach shader 89. Let me check. '89 init shader program. Yeah, so it's the fragment shader. Something was wrong with the fragment shader, which is what's up here, fragment shader. So I wonder, did I double check? Fragment shader. Resource fragment shader. Varying IP vec2 v texture chord uniform sampler is the R 2D U sampler out vec4 frag color void. Few typos, few bugs. Out storage qualifier. Parameter 2 game 89 96 game 89. So failed to execute attach shader. And its parameter 2 is not of type WebGL shader. Okay, so it's still complaining about that. This. VS source varying IP vec2 v texture chord uniform sampler 2D U sampler out vec4 frag color. V texture chord not control. Okay. Try again. Okay, still something going on. Still uh, V texture, frag color, out, back 4, frag color, uniform, sampler 2D. Uh, Hmm. I wonder if it's a typo in the guide, because this used to be that. Okay, so probably not. Game 40, Game 42, Game 47, init shader program. So init shader program, VS source, FS source, bearing IP, vec2, V texture chord, uniform sampler 2D U sampler, rat color. Rat color is texture U sampler. Hmm. VS source, let me double check this one. Vec4, A vertex position. Vec2, A texture chord. Uniform mat 4. U model view matrix. Uniform map view projection matrix. Bearing high P. V texture chord. GL position. U projection matrix. U model view. V texture chord. A texture chord. U sampler V texture chord. So just looking at this, it seems like, yeah. So everything's accounted for. Texture chord. What's the error message? Shaders out. Okay, storage qualifier supported. Okay, and above only. Interesting. The frag color. Okay, so GL and above. So it could be that the WebGL is a lower version, but I wonder. So let me Google this out. Storage qualifier supported. GLSL. GLSL ES3. Okay. Yep. So out, not Oh, out. Scroll back all the way up to the top. See if I missed anything. So it's creating a program by its, yeah, a mini program. But it seems like the out keyword is not supported for some reason, but it knows. But it also knows WebGL ES 3.5, no position specified for float. No position specified for float. Oh, there is float. So why was this not able to find it? Error compiling shaders. No matching overloaded function found. Precision medium p float. Okay. So according to precision medium p float, according to Google, is what I should do. Add a precision. Now let's see if that fixes. Okay, interesting. So that does fix one of the errors. Out storage qualifier supported and texture, no matching overloaded function found. Okay. Yeah, I was suspecting as much too, that this is not defined. Yeah, so this FS source is all sorts of wrong. But yeah, let's just try to see if what we can do about this. Out storage qualifier supported above only. Hmm. ES3 template. Fragment shader. So first running on and where it's trying to use a feature. Is it this following error? Okay, so maybe I need to, instead of WebGL, I need WebGL2. Canvas.getContext. Let me see if that's what I'm doing. Game. Oh, okay. Wow. This might be, hmm, all right. Okay, so still same error. Get context WebGL2. Or I need to drag color. Okay, so I put it back. Um, so it doesn't seem like get context WebGL2 did anything. But I want to go backwards to the beginning to see what it wanted or what it said. Okay, so it says WebGL. Hmm, not WebGL 2, so that's interesting. Introduction. Let's look at find UV. So maybe this is version 300 ES. I saw that pop up. Must occur on the first line of the shader. So that's interesting. It does support it. Oh, wow. Cool. So that got rid of a lot of reserved code word. Varying. If I take that out. Syntax error, illegal use of reserved code word. Varying. Let's see. So I wonder. Attribute error. Deprecated. Oh, wow. Okay, attribute and varying are deprecated. Okay. Wow. Oh, what? So it seems like they've been replaced. Yeah. So this is uh yeah. So attribute becomes in. Yeah, attribute becomes in, and uniform became out. Yes, no, out. Back for frag color. Out. Oh, there is no out. Okay. Oh, GL frag color. And then you don't need a out. Yeah, so it seems like Um, so it seems like this fragment shader chunk of code is mixing two versions of OpenGL or WebGL, and it seems like the old format that used to have this probably works. Let's try. Okay, no, I can't. Yeah, so yeah, so frag color. So I need to use the new style version. And then yeah, let me see what is it? Outback 4, Outback 4. Okay. And then varying is also an out. That's weird. Yeah, because it used to be varying. No precision. Okay. So I took that out. Feed texture chord. All locations. Precision medium P float. Precision medium. So varying. Varying for color. Mm. Oh, varying is in. Thank you, Google. All right. Try it out. Okay. Game 94. Shader program is not defined. 66, 86, 95, 94. Okay, shader program is not defined. Uncaught reference shader program is not defined. Line 94. Okay. Get program info log. So this was a previous get shader parameter, get program parameter, get program info log. Okay, so it's erroring out because it's coming in here. Init shader program 94. So it's still not liking it. Yeah, so the next line didn't like it. Shader. Link status. Parameter link status. Yeah. Let's see. Let's try to change the vertex shader over as well. In and varying out. Geo position. Okay, different area. 125. So I made the version WebGL consistent. Now let's see 125. 125 GL text image 2D is not a text image 2D. Is it? I think I know it's not text image, it's text image. Like not text, but texture. There we go. Okay. Awesome. This is a glimpse at the life of a software developer. You know, you follow the guides and then troubleshoot where there's errors and keep going until you get the result. And so here we have it. Nice cube with a Firefox. Um, and so it's now 2:51 and I started at 1:30. So the stream has taken a bit more than an hour. I think it's a good place to end for now, and hopefully the stream was captured. But yeah, so first of all, before I end the stream, I want to version control my progress. if I can exit out of this or stop the server. There we go. Okay. See what's changed. All right. The text file, the two JavaScript files. Let's see. Live streamed the 15th. There we go. Oh, hold on. Oh, no. Command prompt. Awesome. Okay. So I copied that over. One thing I should first add the new file. And now commit. Yep. All right. Thank you all for watching the stream. Hopefully, it recorded, and I'll see you all next time.